this is the Chris Milley Retirement Symposium, and we're also having the celebration for Krista Dunn, who's with Chris has been a long-term partner with GFDL. So this is actually, I'm going to kind of speak to both of them here. And I think the core thing here is the unique confluence that Chris and Krista have provided, bringing in their hydrologic modeling expertise, which then has intertwined with GFDL's climate modeling expertise. That's a pretty unique combination, and wow, you know what kind of productivity it has been over the 3 decades. I think it's 3 decades that Chris and Krista have been together at GFDL, and you know you're going to hear a lot about some of the really very wonderful papers that came out, and also the impacts that they've made in terms of the whole field. Now, you know, there was this USGS NOAA memorandum, which basically brought both of them to GFDL as long-term denizens of this lab. And this has really been a very visionary process, and I would really compliment USGS on, you know, putting forward what turned out to be very prescient action in terms of this partnership involving hydrology and climate. It is a very cherished one. It's a very productive one, and I value it especially because of all the really great results that have been outcome of the research. And what this has consisted of is, as you're going to hear in a lot of the talks to follow, is a synthesis of these 2 disciplines, hydrology and climate, which has actually advanced the knowledge on the climate effects on land and hydrology, particularly in the era of the anthropogenic or human-influenced climate change, and what it does to really the whole land hydrologic processes. And Chris and Krista brought in not just their modeling expertise, but also their analysis through diagnosing some of the really essential processes involved in land-atmosphere climate interactions. And I think one of the things that I particularly like is their novel ways of comparing model with observations, even though the observations probably did not represent a whole you know, complete set, but still they were able to do this and draw some very interesting interpretations, which actually not just advance the physical understanding, but also the societal significance of their research. Can I go to the next slide, please? So there are a lot of publications that have come from Chris and Krista. I'm just sort of going to touch base here about 4 of them, which I, you know, I think I understood them well enough to really speak just briefly about them. I think the 1992 Chris's publication on potential evaporation was really a revelation in terms of how continental evaporation was being parameterized in GCMs and what its consequences were, including sort of, as Chris put it, that it was really inconsistent with the empirical work on which the parameterization was based. And this had ramifications for the sort of the modeled actual temperatures to evaluate the effect of the land atmosphere interaction, and it missed out on some key things. And also, of course, it affected the soil moisture determinations. So this was kind of quite a sea change in terms of influencing the climate community to think about potential evaporation as sort of the important parameter. Then there was this paper by Chris and Krista, with Dick Weatherall and Tom Delworth on the increased risk of great floods in a changing climate. And this is probably the first time a GFDL model exercised towards this effect, consisting of realistic forcings, both greenhouse gas and aerosol forcings. And what the paper did was to look at the natural variability as well as the force changes in flooding. And they recognized that there was a lot of uncertainties about the observations of stream flow trends. So they focused on sort of the bigger flood discharges, or bigger discharges, and from basins larger than, I think, 200,000 kilometers squared. And essentially found that the frequency of the great floods had increased in the 20th century, and of course that in the future also that it will continue to increase. Then another paper that struck me was this paper with Kazinev and Gennaro, which talked about the contribution of changes which are climate-driven in continental water storage to sea level rise. And the upshot of this was looking at the eustatic contribution as well as the steric contributions and determining what sort of the relative magnitudes were, and finding that there was a consistent observations when you actually took into account the natural variability. And then the last paper on this slide is the paper with Suki and Dick Wetherill on the long-term changes in river discharge and soil moisture as global warming keeps on going. And this talks about the really big discharges you're going to find in the high latitude river, actually the Arctic basin rivers, as well as in the tropics, in the bigger sort of rivers, but also the effects that are a little bit marginal in some of the other tropical rivers which are probably not as large. So I'm probably not talking to really all the significance coming out of these papers, but these papers have been ones which kind of drew particular attention for me and particular appreciation in terms of how they were linking the hydrology and climate issues using realistic hydrologic theory and models as well as climate models. Next slide, please. Okay, so I guess this is really has to be one of the signatures of Chris's foray into hydrology. It's a very remarkable concept. I mean, taken as such, just saying stationarity is dead. Yeah, so climate is changing. So it's maybe something thought of as a routine thing. But what this actually is, there's sort of two papers that I thought illustrated this. One was the paper in groundwater news and reviews, which I think was in 2005, and then later on there was a paper in Nature. I think what is important is not the fact that stationarity is dead, yeah, so climate is changing, so things are non-stationary, but I think what Chris succeeded in doing this was relaying a simplicity of the concept in the fact that climate is changing due to the forced changes in atmospheric composition, and that the future is not similar to the past. But I think what he drew upon is the implications that result for infrastructure and the management of hydrology. So typically, the dams and floods, levees, infrastructure. And Chris, when kind of pointed out the models have limitations and gaps, and projections have uncertainties due to a lot of things besides, the fact that atmospheric composition uncertainties may be there, but the broad implications are robust. So this is sort of underscoring that you might have uncertainties, you might have gaps, but you are left with this implication which you can't escape from. And so annual runoff effects was something that was pointed out. But then Chris goes on further to say that accompanying factors, which might be due to the role of human beings in the face of aridity and the face of water shortage, and that would just add to the impacts due to climate. And then also it was recognized the additional complexities which are not in models, such as groundwater being treated explicitly, the partitioning of snow and rain, but that there's a sort of a unidirectional component to this, which is that it's only going to exacerbate the issues due to the river shortage, due to the reduction and the change in the hydrologic cycle. And that particular article actually goes further into talking about sea level rise and the water flowing into the sea and salinity issues interfering with the groundwater, and also coastal water issues and management. All this, I kind of put these things in because these are all relevant today in terms of the downstream effects of the climate changes and hydrological changes. Next slide, please. And this is a figure from that groundwater news and reviews. And I think this particular article really focused on the Southwest because from the model simulations, there were, and actually the statistically significant changes in the runoff, decrease in runoff, basically 40% decrease in runoff, and then corroborated by most of the models. So a lot of models agreed on this sign. So very kind of robust finding in terms of the land hydrologic involving water from these models. And I think this, if you go to the next slide, this is also captured in this slide from Chris's Nature paper, which, if you look at the colored regions, those are where they say 8 or more of the 12 models agreed on the direction of the change. And most of the browns and the reds are decreases. I think the reds are up to 40% decrease in the runoff volume from ice-free land. And so this is by the middle of the 21st century relative to pre-industrial, relative to actually 1900 to 1970 period. So substantial changes in the runoff, and which is kind of emerging now consistently across models, and including successive models from GFDL. So this is a lasting legacy from Chris and Krista, the work they've done as part of the research at GFDL. And I want to thank both Chris and Krista for their really invaluable contributions and really anchoring the hydrology, the land hydrology and climate interface at GFDL. And thanks also go to USGS for making this possible. And certainly NOAA has benefited a lot from their work here. So once again, thanks, Chris and Krista, for your enormous work. And I kind of hope that you will keep the partnership going, because there's still a lot of intellectual things we want to tap from you as GFDL continues its climate research. Okay, I'll stop there, and John and Kirsten, back to you.
Thank you for those words, Ram. It's really nice to hear your perspective on how enormous the contributions of both Chris and Krista have been over these many years of their collaboration with GFDL. So thank you, Chris. We want to give you a chance to, after each presenter, to, if you so choose, ask a question or make a comment. You get first dibs, but otherwise.
Yeah, you just took me off guard.
Sorry.
Thank you, Ram. You've been more than generous with your interpretation of the contributions there, and I appreciate your mentioning the, how essential Krista has been also. It's really about the project